Hi fellow students! So today in this video, we are going to learn about the gas laws and investigate the relationship between volume and pressure at constant temperature, figures to volume and temperature at constant pressure of a gas, and then 3, explain these relationships using the kinetic molecular theory. And in this video, the reporters will be using a simulation website to showcase how each of the laws work and how they behave when certain variables are tampered. We will be using, of course, the PET simulation to showcase these relationships. So without further ado, let's go start with the lesson. So, what is gas law? First and foremost, gas laws was created in the early 70th century when scientists began to realize that relationships between pressure, volume, and temperature of the sample of gas could be obtained which would hold all the approximation for all gases. The gas laws describe the properties of gases including Boyles and Charles laws. The gas laws assist scientists in finding volumes, amount, pressures, and temperatures when dealing with gas. The gas laws consist of 3 primary laws: Charles laws, Boyles Law, and Avogados Law. Ideal gas law, or also called general gas equation, is the gas law formed when the 3 primary laws of gas are combined, which are Charles, Boyles, and Avogados Law. And with that out of the way, now let's talk about the definition of terms which will be discussed by Kurt Agudo.
Now, before we head to the different gas laws, we must first understand some important terms or fundamental properties of gases that will be key in understanding these gas laws. First is the volume. The volume is the molecules of gases that occupy a space. It may be proven when the gas fills up its container. The units for volume are liters, millimeters, cubic centimeters, cubic meter, and cubic decimeters. Next is the pressure. The pressure is the force exerted by the gas per unit area. The different units for pressure are Pascal, atmosphere, millimeter of mercury, kilopascal, and pounds per square inch. Next one is the temperature. The temperature of a gas depends on the kinetic energy of the gas. The 3 units for temperature are Fahrenheit, Celsius, and Kelvin. Lastly is the amount of gas. The mass of the gas is related to the number of moles of the gas. The units for the mass of the gas is kilograms and grams.
Robert Boyle described the relationship between the pressure and volume of a gas. Boyle's law, which states that the volume of a given mass of gas is held at constant temperature, then it is inversely proportional to its pressure. This relation can also be expressed as the product of pressure in volume is equals to constant. We can also write the formula as P1, V1 is equals to P2 and V2. In the formula, we can see that under a certain condition of the gas, increasing the pressure would result in decreasing the volume. While if you increase the volume, it would result to decreasing the pressure, leading us to this statement in the presentation wherein as the pressure increases, the volume decreases, while as the pressure decreases, the volume increases. This statement shows that they have an inverse relationship to one another. Now with the help of the simulation, I will show you how the Boyles Law works. What we're going to start with is introducing some particles to this chamber. And the first thing we're going to do is looking at Boyles Law. So remember that Boyles Law is when we change volume and pressure. How do they impact each other? So we're gonna assume that temperature is gonna stay constant. So I'm not gonna change the temperature, but I am going to decrease the volume. So to decrease the volume, let's look at what happens to pressure. So notice how pressure went up on this gauge. So let me go backwards this time. So I am gonna increase volume and we're gonna see what happens to pressure. So the pressure went down. So notice how they are inverse to each other, or they do the opposite. And so what I'm gonna do again is I'm gonna decrease the volume and the pressure goes up. So I therefore conclude that for Fx amount of gas at constant temperature, the volume of a gas increases as its pressure decreases. Likewise, the volume of the gas decreases as its pressure increases. Or as the pressure goes up, the volume goes down, and when the pressure goes down, the volume goes up.
Now, I will be the one that will discuss the Charles Law. What is the Charles Law? It is the relationship between the volume and the temperature of a gas. A French physicist named Jacques-Alexandre Charles performed an experiment in a balloon, hot water, and cold water, and discovered this relationship. He found out that various gases expanded by the same amount when heated through the same temperature interval. He then proposed that the cabin temperature and the volume of a gas are directly related when there is no change in pressure of a gas. Volume increases or decreases when the temperature manifests the same increase or decrease. The formula for the Charles Law is V1 over T1 is equal to V2 over T2, where V1 and T1 is the initial temperature and volume, while V2 and T2 are the final temperature and volume of the same amount of gas at the same pressure. Now, I will show you the demonstration of how this principle works by using this simulation, and see the relationship between the temperature and volume of gases. Charles' law states that the temperature and the volume of a gas are directly related when there is no change in pressure of a gas, so the pressure is constant. First, I am going to introduce some gas particles inside of the chamber so that we can begin this demonstration. Then, I am going to increase the temperature inside the chamber, and as you can see, the volume is expanding when I increase the temperature. Notice how the area is getting bigger when I put heat inside. In contrast, when I decrease the temperature, the volume will become smaller. Notice when I put some ice, the large area earlier started to shrink. And by that simple demonstration, we have learned the relationship between the volume and temperature. That is how Charles' law works.
Gay-Lussac's law. So, for the Gay-Lussac's law, the Gay-Lussac's law states that the pressure exerted by a gas varies directly with the absolute temperature of the gas, or in other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. This law was formulated by French chemist named Joseph Gay-Lussac in the year 1808. And the mathematical expression of Gay-Lussac's law can be written as follows. So, the formula for the Gay-Lussac's law is P1 over T1 is equal to P2 over T2, in which P1 is the initial pressure and T1 is the initial temperature, and for the P2 is the new pressure and the T2 is the new temperature. So now let's go and demonstrate this law using the PET simulation. So first, let's pump some gas inside this container. I will use the light molecules here so we can observe it more clearly. And now, let's start increasing the temperature by heating up the container. As you can see, as the temperature goes up, the pressure goes up, and the molecules are moving faster. Now let's try to cool it down. And as you can observe, as I cool it down, the temperature decreases, the pressure also goes down, and the molecules move slower. So, to sum it up based on the simulation that we used, if you heat a gas, you give the molecules more energy, so they move faster. This means more impacts on the walls of the container and an increase in the pressure. Conversely, if you cool the molecules down, they will slow and pressure will be decreased. Now, let's move on to the Avogados Law. So, for the Avogados Law gives the relationship between volume and amount of gas in moles when pressure and temperature are held constant. Avogados Law states that the total number of atoms or molecules of a gas is directly proportional to the volume occupied by the gas at a constant temperature and pressure. Avogados Law is named after the Italian scientist named Amedeo Carlo Avogadro. At a constant temperature and pressure, Avogadros Law can be expressed by the following formula, which is V1 over N1 is equals to V2 over N2, in which V1 is the volume and N1 is the number of gas, and V2 is the new volume and the N2 is the new number of gas. Now let's go and demonstrate this law using the PET simulation. So first, let me pump a little bit of gas in the container, and you can see the gas moving around freely. And then, we will remain the temperature and pressure constant. Now, let's pump more gas and let's observe what happens. So you can see, as I pump more gas in the container, the volume increases. Now let's try to open the lid and let some gas exhale. And now, as you can see, the volume of the container decreases. So, to sum it up, based on the simulation that we used, if the amount of gas in a container is increased, the volume increases. If the amount of gas in a container decreased, the volume decreases given that the temperature and pressure are constant.
Hi, I am Jayson Cruz and I will be discussing combined gas law. What is combined gas law? It is the relationship between the pressure, volume, and the temperature of gas. The three gas laws, Boyles, Charles, and Gay-Lussac's law, is combined and then later expressed into an equation, which is formula, which has the formula PV, pressure times volume divided by temperature, and this is expressed as the general gas law or combined gas law. This law helps us to directly solve for the pressure, volume, or temperature. The N or mole can be derived as pressure sub 1 times volume sub 1 divided by temperature sub 1 is equal to pressure sub 2 times volume sub 2 is divided by temperature sub 2. And now I'll be showing you how the combined gas law works with a simulation. First, we pump some light particles into the container. Now, the pressure will later then increase. The reason for this is that the gas that's in a random motion is hitting the container's wall. We use this gauge to measure the pressure, and we use the thermometer to measure the temperature. We can adjust the motion of the particles by simply adding more or removing the particles. The temperature will decrease if we do remove the particles, while if we add the particles, the pressure will increase. If we put some heat, the pressure and the temperature will increase significantly, and the motion of the particles will move more rapidly. And if we put some ice, instead the pressure and temperature will decrease slowly while the motion of the particles will slow down. If we adjust and add more volume, the pressure will go down, and if we do the opposite, the pressure will go up. Thanks to this simulation, we can see how the combined gas law works.
So now I am the one who to discuss the ideal gas law. So first, what is ideal gas law? So basically, ideal gas law is the volume of a given amount of gas or is directly proportional to the number on moles of gas, or simply, as stated here, the relationship between the volume, pressure, and temperature. So it is based on the experimental measurements of the physical properties of gases, and it is derived from the Boyles Law, Charles, and the Avogadros Law, which the others are discussing. So first, what is the formula of the ideal gas law? Basically, the formula is PV equals nRT. Okay, so first, let us start by adding 100 heavy particles. So again, our constant here is volume. So moving on, as you can see that the particles are moving at their normal speed rate, and again, our constant here first is volume. So let us start by heating up the particles. So if we heat up the particles, you can observe that the particles are moving at a rapid speed, and you can see that of course the temperature increases, and so as the pressure. But if we decrease the temperature, you can see that the particles are moving slower than the heated particles. So of course the temperature decreases, and so as the pressure. So now the question is, what if our constant is pressure? So let us try. So if we observe here that if our constant here is pressure, you can see if we heated up the particles, the volume increases. But if we decrease the temperature, you can see that the volume decreases. So in conclusion, if the volume of the gas decreases, the pressure of the gas increases. But if the volume of the gas increases, the pressure decreases.